Here is question number 3 for you to practice. It is test on dot products. Determine the angle that vector OP214 makes with each of the coordinate axes. So copy the question, pause the video, do the solution, and then restart to check my suggestion. Now when we are trying to find angle using dot product, then simple rule is, let's say there are two vectors u and v, then you know u dot v is magnitude of u times magnitude of v and cos theta, where theta is the angle between them. Now from here we can always find the angle, saying that cos theta is equals to dot product of the vectors divided by their magnitudes, product of their magnitudes, right? And of course theta will be cos inverse of all this, that is u dot v over product of u and v. And that's how you can get your answer. Now here the question is that you are given a vector OP, so we know OP, which is a position vector, right? So the position vector starts from origin, and the axis, when we are saying, then axis is ijk, right? So you can use vector OP as given to you, which is 2, 1 and 4. So you need to find magnitude of OP. That is first thing you need to find, right? So find magnitude of OP, which will be equals to square root of 2 square plus 1 square plus 4 square, right? So that is one thing which you need. So you get 1. Now along the axis we have to use vectors, and the best vectors to use are I, j, k, right? So I is unit vector along x-axis, whose coordinates will be any point you can take, but the best point is 1, 0, 0, right? Similarly, you can take unit vector j, which will be 0, 1, 0, and then you can take vector k, which will be 0, 0 and 1. And then use this formula, right? In this formula, you do OP dot I, for example. So OP dot I will be only the direction number 2, right? So that will give you angle alpha. So you'll find that angle alpha is basically equals to cos inverse of 2, because that is 1, right? Dot product, when you do, you will get just 2 on the top, divided by magnitude of I is 1, magnitude of OP. Do you see? The magnitude of OP, whatever you calculate here, which in this case is 4 plus 1, 5 plus 16, right? Which is square root of, I can write 4 plus 1 plus 16, which is square root of 21, right? So you'll get square root of 21 here. Since magnitude of ijk, the other vector, is just 1, right? So that is how you can get your answer, right? So similarly, beta will be cos inverse of, now we can write 1 over, right, this component, 1 over square root of 21, and gamma, the angle with z-axis, will be cos inverse of 4 over square root of 21. Correct? So that is how you can solve this question. Now I took this opportunity to explain you what are these angles, right? They are also called direction cosines, right? So remember this, these are direction cosines. So as you can see, these are direction numbers, right? So direction numbers over the magnitude of the vector gives you the direction cosine. So that is easy way of remembering the formula. So A is the direction number, right? And this is the magnitude of the vector that gives you direction cosine. I hope that helps. Thank you.